Hello, my name is Leo. I would like to say a few words about my special guest today. Involved in work of a lab at Harvard University, he has researched especially evolution of life and Earth's environmental history. Thanks to his work, we have got not only knowledge about these fields, but also understanding of interconnections between them, about impacts of environment on organisms, as well as influence these organisms had on environment. The main issues he has studied there included also various fieldworks throughout the world, on basins in southern Africa, Australia, and northern Russia, where he discovered microfossil records of early life forms. He is principal investigator of the NASA National Astrobiology Institute team at Harvard and has been a member of science team of 2004 NASA's Mars exploration rover missions, where he has had the important role both as a geologist in analyzing minerals found in Martian rock and as an astrobiologist in exploring possibilities of life forms on Mars. My guest is Professor Andrew Herbert Knoll. Hi, Professor Knoll.
Hi, good afternoon, Leo. How are you?
Fine, thanks for questioning. How are you?
I'm just fine. Looking forward to our conversation.
So, would you please tell us something you consider important about yourself and your work?
Well, I guess if I have any claim to fame, it's that I've worked hard over the years not to be simply an earth scientist or a biologist, but to find those areas where the life sciences and the earth sciences intersect. So, in some ways, my work aims to um, understand biological evolution in the context of Earth's environmental history. And at the same time, I don't think I can understand Earth's environmental history without knowing something about the history of life.
Okay. Could you tell us something from your experience you've had in the numerous field researches? What experience was it for you to travel around the world with the aim of discovering something new?
Well, one of the very happy things about my line of work is that one has to go to where the rocks are that will help me learn about different periods in Earth history. And for early life, which is what most of the work in my lab is about, the rocks that inform us about that aren't found anywhere near Boston. They're found in the Arctic, in Siberia, in China, in Africa. And so it has been a great privilege for me to work with scientists from around the world. And on the one hand, to see rocks from around the world that have helped us to understand our planet's history, but also at the same time to make friends with people around the world and really experience different cultures. So it's all very enjoyable.
Could you tell us about your role in Mars exploration rover mission? Is it an exciting challenge for you to explore extraterrestrial life forms?
Well, it has been fun and tremendously interesting to work on the Mars rover team. Really, I almost got into that work by accident. That a man named Steve Squires, who was the leader of the MER mission, invited me to join the proposal team simply because he thought it would be useful to have a few people who had experience interpreting ancient rocks on the team. And that's turned out to be the case. As you probably know, uh, what we know about our own planet's history comes largely from sedimentary rocks that are laid down layer upon layer through time. And we now know that Mars has sedimentary rocks. And so, in many ways, the work I've been able to do on Mars over the last 15 years is very much an extension of what we do on Earth. We look at the chemistry and physical characteristics of rocks, and on the basis of that, we try to learn about the history of another planet's environment.
Could you describe what does your life as a scientist look like? What are key elements which motivate you as a scientist to research and inspire you for your further work?
Well, I think that the common thread among all good scientists is curiosity. If you don't wake up in the morning wanting to learn something new, wanting to know how the world works, then science won't be very interesting. Um, Science is it takes a lot of dedication. It takes a lot of time and effort. But for someone like me, the idea that I can actually learn something new, find a new fossil that no one has ever seen, come up with an idea that no one has ever had before, that's all very exciting, and it you know makes me get up every morning and want to come to the
Hmm.
lab.
Which qualities you consider important for someone who works in science to have?
Well, again, I'd start with curiosity, but I would move on from there. Uh, I think the ability to stick to a problem, and when things get hard, you don't give up. That's always important, because in science, inevitably, if you're doing an experiment, it won't work, or if you're, in my case, going to an outcrop expecting to see one set of things, you may not see them. And so, in some ways, it's having the drive and the stick-to-itiveness that allows you to keep on going, despite the fact that things commonly don't go well.
Yes. What do you think is the best way to become scientist today and succeed in scientific career?
Well, I think always, to become a scientist, one needs to just learn very broadly the basics of science, and that I would include uh, mathematics as well as chemistry and physics, which of course underpin much of what we know about biology and the earth sciences. So I think, particularly at the level of students starting out, just getting a good background in science is important. And I think more and more now, things are changing in science a bit. That when I was your age, the best advice, I think, for a young scientist would be to find one narrow problem and drill as deeply into that problem as you can. Uh, there are many people who still do that, but much of the most exciting science, and much of the most important science in terms of, say, our environmental future, comes from actually crossing disciplinary boundaries and using the tools of biology to learn about the earth sciences, or using the tools of earth sciences to learn about different planets. So we do live in a world where much of science is interdisciplinary, and so therefore, in addition to knowing very well one set of things that you do, it's important to have at least a broad appreciation for science so that you'll understand how you can collaborate usefully with others.
I'm very interested in science and I think about once becoming a scientist. I know how much work waits for me to do before. What are strategies of how to bring a new theory and how hard is it to defend it and get it recognized in science world?
Well, that's a good question. An old friend of mine named David Raup once said that in science, every idea is wrong until proven otherwise. And I think that's pretty much the way scientists act. It's not that they're mean spirited, but I think there is a natural skepticism that whenever we read a new idea, we think about all the ways it could be wrong. And I'm sure that's what everyone thinks when I write a paper. It's what I think when I read papers. But it really is that skepticism, healthy skepticism, that makes science work, because all of us do make mistakes, but because we have this broad community of scientists, the system corrects itself. So I think in some ways the best advice I have is that when you have an idea, be as honest with yourself about its strengths and weaknesses as you can be, and also think about how others will perceive and think about your idea, and maybe anticipate what some of their reactions will be. So I know my idea is far better when I actually think in advance, you know, how is a cell
Yes.
biologist going to respond to this hypothesis? How is a paleontologist going to respond to this hypothesis? How is a planetary scientist going to respond? And the better job I do in thinking about how others will receive and think about my ideas, the more successful I'm likely to be in defending those ideas.
Yes. Could you advise something to future scientists, young people like me and others interested in science?
Well, first of all, I think that it's a wonderful time to become a scientist. Um, as we talked about briefly earlier, science is moving beyond the individual disciplinary silos of chemistry or physics or biology, and is becoming very integrative. And that will help us to learn fundamental things about our universe. And it's also very important in thinking about sort of practical things about our future, for example. I think in a world with global warming, one has to be able to think about ecology, chemistry, climate, all in the same breath. And so I think my advice would be to not only learn one thing well, I mean, you do have to learn to be a good physicist or a good biologist, but develop what some people call scientific peripheral vision. That is, learn enough about other disciplines so that you can appreciate the relationship between what you're thinking about and what other people are thinking about.
Do you have maybe something more to tell us, to add?
Well, I think just that, having spent the last 40 years in science, I'm very glad that I did it. I have been able to see the world. I've been able to discover things about the world, discover things about other worlds in my life as a planetary scientist, and to make friends from all over the world. And I think that science is an unusual discipline in that regard, in that it is very international, it is very welcoming to new ideas, even though they're going to get very hard scrutiny. So I would encourage you and others who are thinking about science to go forward and take your own place in the laboratory and teach us something new about the world.
Thanks, Professor Knoll, for this very interesting interview. It was my pleasure to interview you and to hear your sage pieces of advice. I
My
want
pleasure,
you,
Leo.
I want you all the best and good luck in your future work.
Good luck to you, Leo. Thank you.
Thank you very much.